Hello everybody, welcome to yet another video. Now this video is going to be a bit different because I'm trying to explain an advisory that was released by Okta some time back. Now this one is from Pure ID, and as you can see it's from November 7, 2024, and the title is Okta Password Bypass, Cryptography Done by Non-Experts. Now I'm going to try to explain it using a flowchart diagram so that you can understand it, but it's purely based on the advisory that I've read and something that I've understood from this. So let's start. Now it says Okta password bypass. Now this was special because you do not need to be a security expert or need to be have your hands on penetration testing in order to kind of exploit this. So let me try to explain it to you with the help of this neat diagram. Now, typically let's say that you are on a web app and you go to the slash login endpoint. And let's say that login endpoint is configured with Okta. Let's also assume that there is no MFA or any sort of authentication involved. It's just plain simple old username and password fields that you are expected to provide. Now, what do you think what happens when you try to log in using username and password? So one simple guess would be to see if it'll check if the username actually exists. All right. If it does, well and good. If no, it'll just say 404 not found and show you an error message, and along with that redirect you to some login page or some other page, right? But what happens if that login or username exists? So here things get a bit tricky because some companies or companies or websites, what they will do is they will just store the hash of your password in their database. But some go an extent further and use salts. Now you can study about salts. This video is not going to be about that, but what will they do is like they will concatenate, prepend or append that salt with that password, or they will just mix and match, like they'll mix that salt with your password and find a hash out of it, and then they'll store it in their database. Now, if they store a simple hash of the password, they will find out the hash of the password and look for that hash in the database. Now, if they have used salts, they would again run some algorithm and then they will find out the hash of that resultant thing, for example, salt and password, and then they will check it in the database. It will match again against all the entries in the database. If it exists, voila, you will be logged into your website. You might get redirected to slash dashboard slash index.php or whatever. But if not, again, you will go to slash 404 not found. Okay, so now we have a basic understanding of what is happening, right? Now this hash thing is somewhat important in here. Now, what Okta used to do is Okta, like there are a lot of things that have come up while I was reading this article. Like for example, Okta used to use store plain text passwords for some things, and it was also using Bycrypt hashing algorithm. So let's study about Bycrypt because this is where the issue crept in. Now, Okta used to use Bycrypt and still probably uses Bycrypt for hashing their username and passwords. And they also use the blowfish algorithm within crypt library or Bycrypt. All right. So what is special about blowfish algorithm? So the thing about algorithms or like these hashing algorithms is like, for example, let's say you have a very long string. You can find out the hash of it using SHA-1, SHA-2, SHA-5 and 12 or whatever. But with Blowfish, it can only use up to 56 characters. And within those 56 characters, four are reserved for denoting the version of the Bycrypt algorithm because there could be multiple Bycrypt algorithm, right? So you have to know like which Bycrypt algorithm or like with how many cycles or repetitions were used. So these four are for that, right? Now, if four are reserved for donating the version and there are 56 characters, then what is the effective character length that remains? So it is 52. Okay. Now we know that out of whatever you enter, only 52 are being used for hashing, right? So what is special about Okta is that they use a cache key for authentication, and that cache key is built up of user ID, username, and password. Now this is where things get really interesting. Now if you see user ID, username, password, and then there are two delimiters as well, like 1 and 2, right? So what would happen if the length of this exceeds 52 or is exactly 52. Now, if it is exactly 52, you will know that the password will get truncated and only the hash of this part and this part would be stored, right? So this is what was happening. So if the length of user ID and username is either greater than or exactly equal to 52, let's say if it is exactly equal to 52, then you will be able to log in just using your username, because user ID is something internal, right? You can't do anything about it. So you can just log in using your username. So this is like what was happening, and just using username, you could potentially log in to anyone's account, like provided that the user ID and username were like exactly equal to 52 or more than that. So this was like the advisory. I hope you like understood what the thing was. All right, thank you.